तो कार्टेशियन इक्वेशन देखो, if we have given this condition, how we will write directly a Cartesian equation? If a line is passing through a point, I'll draw, instead of writing, I will show you that this line is passing through a point, okay, whose coordinates are x1, y1, z1. And drs of this line are, see that drs of this line are A, B, and C. Take this line as PQ. So what will be the equation of the line PQ? In which form? Cartesian equation. Directly we are taking Cartesian equation, then we will write how to convert, and then we will do some questions on it. So Cartesian equation of this line, okay? So its Cartesian equation will be Cartesian equation of this line A PQ, Cartesian equation of PQ is, it will be x minus x1 divided by first dr A, then y minus is equal to y minus y1 divided by b, and z minus z1 divided by c. And if you want to write any point on this line, so you can write the values, equate it to lambda and find the value of x, y, and z. No need of that, just you go step by step. First of all, if this is the first condition, when a line is passing through a point and having drs, point and drs, what is given? Point and dr, passing through a point and drs are given. Then how to write this equation? Okay. Second condition, suppose if you have given DCs, if DCs are given and this is passing through a point, similarly, if a line passing through a point, passing through a point A, x1, y1, z1, and its DCs, direction cosines, DCs are L, M, and N. You know that we are denoting the DCs by L, M, N, and DRs by ABC. Then its equation will be, equation means Cartesian equation. So its Cartesian equation is x minus x1 divided by L is equal to y minus y1 by M and z minus z1 by n. Now the question arises, if some equation is given, suppose you have given some equation x minus 1, suppose for example, if we take that an equation is given us that x minus 1 by minus 1 and y minus 1 by minus 4 and z minus 3 by 2. This is the equation of any line, suppose, let us suppose it. So how we will recognize that whether it is a DC or DR? So I told you that sum of the square is equal to 1. It will be always in fraction or 2 zeros and 1 1. Then only their square will be equal to, here 1 square plus 4 square plus 2 square is not equal to 1. So these are the DRs. So DRs of this line are minus 1, minus 4, and 2. So this is the extra thing. Now you should see that if the equation is given, I am talking about the reverse of this one, but we are going to write the equations when the conditions are given. Okay. So if you have asked to write the equation of a line passing through a point whose DRs are given, A, B, C, then you can write by this way. DCs are given, also you can write by this way. And any point on the line, you can equate to lambda and find x, y, z. Okay. Next, how to convert? How to convert equation of a line in Cartesian form? We have seen that r is equal to a plus lambda b. In that, what we did to convert? That is the method. Just you put the value of r and then equate the coefficients of I, j, k. I think no need to write the method. You just put the value of r, xi plus yj plus zk. Put r is equal to xi plus yj plus zk. If the equation is given in vector and you have to convert into the Cartesian form, and then you put this value in the equation, value of r, and equating the coefficients of x, y, or comparing, you can say comparing, then comparing coefficients of I, j, k, I, j, and k. This is the way to convert vector equation into Cartesian form. Vector equation into Cartesian form. That we did in the first derivation. Okay. Now we can have some questions so that you can understand better. Now we are taking one question. No? Find the vector and Cartesian equation of a line. So both, they have asked both values, means both forms, Cartesian and the vector form. Find vector and Cartesian. Vector and Cartesian equation of the line passing through the point whose coordinates are 5, 2, -4, 1 point, and which is parallel to the vector, which is parallel to the vector 5i plus plus j minus 7k. Okay, so obviously this is, you know that first of all you should decide that which form is this. So equation of a line in vector form is here r plus vector a plus lambda vector b. This is the first form. Now what is r? This is the general form. Now you have to write it in vector form. Means values are given. So, or we can write first what is given here. Here, no need to write r. R is always, or you can write in the beginning, r is equal to always xi plus yj plus zk. It will not change because this is the general point. And a, what will be the value of a here? Because the point is a1, a2, a3. So a will be equal to 5i, correct? 5i plus 2j and minus 4k, k cap. And vector b is this one. Vector b is 5i plus j cap minus 7k cap. Okay. Now we can substitute the values, and first we will get the vector form. First we will have the vector form, then we will convert into Cartesian form. Substituting these values, we get vector r is what? Xi plus yj, xi plus yj plus zk, xi plus yj plus zk is equal to a. Vector a is what? 5i plus 2j minus 4k plus lambda times vector b. Vector b is this one 5i. Vector b is this one 5i plus j minus 7k. This is the answer. This is the answer in vector form. Okay. Now for Cartesian form, now for Cartesian equation, how we will do now for Cartesian equation? For Cartesian equation, for Cartesian equation, write equating, or first write xi, left side is xi plus yj plus zk, that we did in the first form. Now I take out the I coefficient common, so y plus I common, y plus 5 lambda I, then j is 2 plus lambda j, and this is minus 4. So either you take minus 4 outside or inside, it doesn't matter, you can write plus, then minus 4 minus 7 lambda k. Now comparing coefficients of ijk, comparing coefficients of I, j and k. On comparing coefficients, we get left side is x, here it is x, coefficient of x is coefficient of I is x, right side the coefficient of I is 5 plus 5 lambda, left side is y, right side is 2 plus lambda, and z is equal to minus 4 minus 7 lambda. And find the value of lambda in each case. So x minus 5 upon 5 is equal to lambda, y minus 2 upon 1 is equal to lambda. When there is no value, you should write 1 here, because we have to show the drs, and this will become z minus 4 divided by minus 7 lambda. Numerator should be written z, x and y should be positive. Denominator can be negative, drs can be negative. So therefore, the required equation, the required Cartesian form of the given equation, therefore the required Cartesian equation of the given line. 1 minute. Of the given line. Yes, what happened? It is z plus 4. Yes, sorry. This should be z plus 4. Correct. Z plus 4. Sorry. So, required Cartesian equation of the given line is x minus 5 upon 5 is equal to y minus 2 upon 1 z plus 4 upon minus 7. So it is passing through the point, you can see 5, 2 and minus 4, because z can be written as z minus minus 4. Okay. So if the equation is written, we used to use in our college time for 3D, we used to represent it by 1 minute. It is not responding. Yes. General equation we write as x minus alpha upon, if ABC we are representing A, and y minus beta upon B, then z minus gamma upon C, then alpha, beta, gamma are the points which lie on the line. P is the point lying on the line, and any point on the line will be A lambda plus alpha and B lambda plus beta and C lambda plus gamma. So in general, just you have to write the formula, substitute the values, and in order to convert into the Cartesian form, you have to equate. After substituting the equate the or comparing the coefficients of ij, and what are the dr of x-axis. Or yes, drs of x-axis are what? 1, 0, 0. So x-axis means this is x-axis, suppose, and it is passing through 0, 0, 0 always. Origin 0, 0, 0. So x a1, a2, a3 is, so therefore the equation of x-axis will be equation of x-axis. It is passing from 0, 0, 0. So x minus 0 upon its dr 1, y minus 0 upon 0, and z minus 0 upon 0. Okay. So y is equal to 0, x is equal to 0, and y is equal to 0, z is equal to 0, and x is equal to 1. Okay. Similarly, equation of, you don't think that this is, we are putting 0 denominator, so it will become infinity. No, we are not going to find the value here. We are going to represent the line. This is the way of representing the line in 3D. Whether in denominator we are getting 0 or not, it doesn't matter. Only the zeros are telling us the direction cosines or direction ratios. So here, this is direction ratios as well as direction cosines also, because their square, sum of their square is also equal to 1. So similarly, the drs of x-axis, so equation of x-axis. Similarly, we can write the equation of y-axis. What will be the equation of y-axis? Y-axis, equation of y-axis will be, again, it is passing from 0. Any axis is passing from 0, 0, 0. So y minus 0, z minus 0. So numerator will be same. Only here x is 1. If it is y-axis, it will become 1. These two will be 0 because drs of y-axis will be 0, 1, 0. Correct? Similarly, the equation of z-axis, the equation of z-axis will be equal to x minus 0, because it is passing through 0, 0, 0. But this will be 0, this will be 0, and this will be 1. Because drs of z-axis are 0, 0, 1. Now next is Equation of a line. How to write the equation of a line? Equation of a line passing through two given points. Passing through two given points. Two points. Now, this is, you know that this is y-axis, z-axis, x-axis, y-axis, z-axis, and there is a line. There is a line here. This is a line which is having 2 points. There are 2 points on this line, A and B. P point is always there whether you represent or not. P you should represent. P is any point which is having the position vector R. It always exists. B and A. So what is the position vector of A? OA. OA is the position vector of A, and position vector of B will be OB. Okay, and it is denoted by capital small a and small b. So only 2 points are given. Suppose the points are given, we can write their vector A. Suppose the coordinates of the points are A1, A2, A3. Coordinates of the point A1, A2, A3. Then we can write the vector A. Vector A or vector OA is the same thing. Position vector of point A is A, and it will be A1I plus A2J plus A3K in component forms. A2J plus A3K. Similarly, if B is a point whose coordinates are given B1, B2, B3, then vector B will be equal to B1I plus B2J plus B3K. So whether you have given position vector or the point. If the position vector is given, you can find the point. Suppose 5i plus 6j plus 7k is the position vector of A. Then 5, 6, 7 is the coordinates. Okay, so same thing. But how to write the equation in this form? Equation of a line through two given points is written as vector A, R is equal to vector A plus lambda times. Before that there was a vector which is parallel to this one. Now B minus A. B minus A. 2 points on the same line are given. There is no vector given except this line. Then we can find the equation by this way. And Cartesian equation, the same equation, if you will convert into the Cartesian form, can I write directly, or if you can do it, you can put the values and equating. So you get Cartesian form as Cartesian form is same equation passing through the 2 points x1, x2, x3. Generally we are taking x1, x2, x3, a1 instead of a1. So equation of this line will be x minus x1 and x2 minus x1, y minus y1, y2 minus y1, sorry, y2 minus y1, z minus z1, z2 minus z1. If you remember, what is the purpose of remembering if direct Cartesian form? Because sometimes the question comes for writing only Cartesian form. So no need to think about the vector form. Directly in Cartesian form, you can put the values x1, y1, z1, x2, y2, z2, and you can get the answer if only Cartesian form is asked. Like in the next question, the question is if y coordinate of a point P or the join of PQ is -4, find it Z coordinate. Okay. This is find the Cartesian and vector for the line passing through the 2 points. Okay, so 2 point we can find out. Now angle between the two lines he will do. Before that, some questions. We have to practice some question. I am writing here one question. You can practice this question and then you can come in the next class. Find the Cartesian, in short form I am writing, find the Cartesian and vector equation of a line passing through a point whose coordinates are -1, 1, 2, and point B whose coordinates are 2, 4, and 5. So write both the forms. It is not necessary, I am telling you again, it is not necessary to write first vector form and then Cartesian form, but it is easier. So you can do it Cartesian form first and then vector form. Otherwise, I will suggest to write first vector form and then you can equate to get the Cartesian form. That is easier way. Okay. So that's all for this class. Thank you very much.